The main reason for using electrical vehicle is to decrease the pollution in the society. Nowadays, pollution is increasing in the society. People also facing many problems due to the pollution. So we want to decrease the pollution by using the electrical vehicles. So nowadays there are less electrical vehicles. So now we are using electrical vehicles in the types of vehicles, batteries.
For the first level, we use for scooters, bikes, like that. And for mainly, this project is about first level, second level, and third level. We are using level 1, level 2, and level 3 charging in this project.
Initially said about the title. Title means the multi-level electrical vehicle charges. In our world, having the only single level, either level 1 or level 2 or level 3. But we are now updated about the multi-level electrical vehicle charges. The level 1 is said about the level is said about car, normal two-wheelers. The level 2 is said about the four-wheelers. The level 3 for multi-level like buses and lorries. So how we construct the battery system means, first battery completely based on 3 steps. First one rectification, another one inversion, another one also rectification. So these are the 3 levels mainly used in the electrical vehicle charges. Now we are using the theorem is novel algorithm theorem. Novel algorithm theorem is used in this system. So digital signal processing also present in this. So while we are doing the hardware model, it will occur. But now we are doing the simulation process. So we can use this complete circuit diagram. Please come. Mainly charges are 2 types. First one is onboard charging. Second one is offboard charging. What is the difference between onboard and offboard? Onboard is while the conversion of the AC to DC present in the vehicle, but offboard the conversion of AC to DC not present in the vehicle. So we need to direct the charging DC to DC. While here you are seeing the onboard charging is basically known as AC to DC charging. The charger is present in the electrical vehicles. So this type of chargers used in the level 1 and level 2 for single phase and 2 phase, 3 phase. For offboard charging are mainly used in the level 3 vehicles. Where we are using the level 3 vehicles? Where the buses and cars. These are the once we observe that single phase AC, control device and connector and charger. Here offboard charging, charger is out of the vehicle. So why we using offboarding or charging? Charger weight also affect on the more, while level 3 vehicles are very high amount of, while we using the level 3 vehicles are very bulk amount of like buses and lorries, it is very heavy. So where the charger amount also present on that, it will help, it will increase the weight also. Onboard charging while major used in level 1 and level 2, where the vehicle weight is very less. The offboard charging is very widely used in the level 3 vehicles, where the vehicle weight is very more, like buses and lorries. So here this type of charging types are used in this. So level 1 having, basically we are using level 1 1.4 to 1.9 kilowatts, level 2 7.7 to 25 to 26 kilowatts, and level 3 50 to 100 kilowatts. So how much time to charge the batteries? First one 6 to 8 hours, because single phase charging is taking very more time. Basically our phone charging takes that to 20 to 30 minutes nowadays, while the charging of 1.4 kilowatts of battery, it takes 6 to 8 hours. And level 2 it's a 3 phase supply, now it is 4 to 8 hours. Level 3 DC to DC charging very fast when compared to AC to DC charging, so it takes 1.1 to 3 hours. This is the timings of the batteries. This is our simulation diagram. Here 3 phase supply, voltage supply is inserted, then R and L, LC filters also applied. Why we using RL? RL means it decreases the distortions of the input supply. Another way, when we having the three phase supply converted into DC. Why we using DC? because we need to decrease the level of the distortions. Then after rectification of the input supply, again we need to inversion. What is inversion? The conversion of DC output to DC input to AC output. This is the process of inversion. While in this inversion type, sinusoidal pulse width modulator is using this, and then we need to LC. LC using for the filters. Why using these filters? To decrease the distortions. Why I am using completely distortion? Distortion is the main backlog of the BMS, battery management system. So once we need to decrease the distortion, we can increase the life of the battery. Actually, the NEC, National Energy Code, said the 5% of the distortion is allowable. But we need to decrease that level, we can increase the battery lifetime. One thing I think about one journal says about the conversion, decrease the distortion effect on the economy also. One fossil fuel vehicle consumes 1.3 rupees per meter. Again, sorry. Why in the word of distortion? Distortion is the main key point of the BMS, battery management system. The complete electrical vehicle concentration on the batteries. Why the batteries and distortion are interlinked? When the distortion increases, battery life increases. Decreases, it increases. So both are inversely proportional. So once we need to discuss about the fossil fuels along with the electrical vehicles. Fossil fuels consumes 2 rupees per kilometer, but this electrical vehicles consumes only 0.30 paisa. 0.30 paisa INR, Indian national rupees only. So we can increase the economy also. We can stable the economy also. If you increase the battery lifetime for 1 year, it takes lots of money to save. So we need to discuss about the how to decrease the simulation of the how to decrease the electrical vehicle charges of the batteries. So we need to discuss about the circuit diagram in this MATLAB. Okay, got it. These are the levels and voltage current ratings and which type of vehicles are used in our daily life. Level 1, you have 120 volts and 16 amperes AC for motorcycle. While using the electrical vehicle for the lowest destinations. Level 2, 240 volts and 60 ampere current for AC 3-phase for saloon cars. Level 3 for 650 volts and 100 amperes DC to DC conversion while using the bus and lorries. These are the basics. And how the stage 1, the circuit diagram classified into 3 stages. Stage 1 for conversion of AC to DC, we can use pulse width modulator VOC, voltage oriented control rectifier. For stage 2, DC to AC conversion. For its inverter, you can use sinusoidal pulse width modulator. Stage 3, diode bridge rectifier. While doing the charge the level 3, you can conversion into only for DC to DC charging because off-board charging. Why I am using off-board charging? Because the level 3 vehicle weight is very more. So that's why we need to decrease the battery vehicle weight. These are the basic concepts. Now we need to show about the MATLAB simulation, the complete process. One more thing, how the conversion is doing, I will show one flow graph. Here 3-phase supply is present. The 3-phase supply is converted into AC to DC conversion. Again DC to AC conversion. Again we can use this isolation transformer for suppression of differential voltage levels. Then we can get the output. These are the complete flow diagram of this our project. First 3-phase supply is coming from the
3-phase supply is converted to AC to DC, and AC to DC is converted into DC to AC. Here
suppression of isolation transformer conversion into suppression of differential voltage levels and get the output. This first line completely open loop sound. While we can use to control the harmonic distance, so we can use the control system. These are the open loop system. So we need to decrease the harmonics using closed loop system. While using closed loop system, we can use the PI controllers and the artificial neural networks. So these two are playing the main role. Pause it. this is the my artificial neural networks code in MATLAB. This is completely my MATLAB code. So after inserting this code, we can get some how the transition will be appears. I will show this. Here we are observing one distortion wave is complete, then output gets it completely without harmonic distortion. So this how the artificial neural networks works. When the one we using some waveforms appears in the circuit, it will appears like it is having some disturbances. So it will convert it into disturbances into straight line. This code will perform like that. So this is my simulation diagram. Each level of simulation I will show you with clear impact. This is my directly showing the stepwise. The first one is input. Here the input, RC for harmonic distortion regulation of the input, and VOC rectifier circuit it is. I will show in deep, and inverter circuit it is, and filters L and C. LC filters. This is the isolation transformer, and this is the rectifier. Diode bridge rectifier it is. Then we can get the battery charger. So in rectification, this is the my rectification circuit. I am using the SCRs here, SCRs and diode the combination in rectifier using power electronics. While this is the VOC controller. Here VABC. This is the input. This is the input current. This is the input voltage. This is the alpha beta naught means the input voltage is compared with reference voltage. Now we can get the VD, VQ, ID, IQ. What is VD? VD means input supply, VQ means reference supply, ID means input current, and IQ means reference current. So this is the complete block diagram. So this is single pulse wave generator. Why we using wave generator? Giving for pulses. Here I am using my code artificial neural networks. The code inserted in this block. This is for voltage oriented control rectifier. And now I am going to voltage oriented control inverter. Here inverter it is. Inverter circuit by using the power electronics and single pulse with modulator controller. This is the controller circuit. I am using the triangle for the reference wave. So I am getting this voltage and current. This is the complete my controller circuit. For after simulation this, I can get these harmonic distortion levels. Here we can see the 1.50 distortion. Initially I said the NEC having 5% of distortion. My seniors, my base paper having 2.50, but I will decrease to 1.50. It will help to increase the battery life while decreasing the harmonics. This is for level 1. I will show now level 2. What is level 2? Level 2 having 3-phase supply. I will show the each level of distortion also here. Phase R, phase Y and phase B. This is my power guy. Why we use power guy? While using for FFT analysis and tools, all the MATLAB simulation guys are present in power guy. Here KH2 extension, input 1. This is for 1.81 because 3-phase supply having little bit more. For Why 1.09? For level 3, 1.09 as usual. So while we decreasing the harmonics, it will increase the battery life. This is the main concept to teach the about, to tell the society. So we have to decrease the distortions to increase the battery life. Why we using increase the battery life means it is economically stable. That's why we need to do this. Again, while after doing this all things, decreasing also, which type of battery we need to use? We have lead ion battery, lithium ion battery, nickel cadmium battery, lots of batteries are present in there. But which type of battery we need to use? So here we need to test the level 3. Level 3 having DC to DC conversion. While using to DC conversion, which battery gives the very low transients? While getting the high transients, it will help to decrease the battery life, or it gets the short circuit also. Transient means the higher currents, the peak time present in the circuit. So we need to settle down at which battery using the very less transients to get the steady state. What is steady state? Steady state means when while using the one power electron device or any battery, it gets some transients. So while getting transient, it makes the lot of loss. So we can decrease the transient and get the steady state as possible. So we need to test on 3 types of batteries. First one is lithium battery, lead battery, along with nickel cadmium battery. So I need to show about the lead acid battery. Here my lithium ion battery is present. Lead acid battery is present. So here you can show the 140 amperes of current having 0.20 only. It very less while compared to other. While using single phase having 1 point something, while level 2 1.09, for level 3 0.20. It's very less harmonic distortions when compared to other batteries. So I will prefer to lithium ion battery because it's having very less transient time. Well, I will show in scopes what happens in this. Here now we can do what happens. This place having transients, while getting 360 above rating of voltage, having the 380 maximum. So while getting the 350 amperes voltage with steady state. This is for now I'm showing lithium ion battery, lead acid battery next, lithium ion battery. This is very less when compared to that. So now I am showing how the simulation will be occurs here. Now when compared to this, it very less harmonic distortion. So this is the main theme to get this project as my career objective. Thank you.
Before we read the project controllers. For extension, we did the project on ANN. So for the future scope, we can did the physiology and CSS and CNN technique.
In this project, we have discussed about the 3 levels of electrical battery charging. In this project, we got the best results for the lithium battery. We have tested for the lithium ion battery, lead acid battery and nickel cadmium battery, and we got the best results for the nickel ion batteries.
Electrical vehicles are very eco-friendly with environment, so ever to use the electrical vehicles for future environment, which is future.
So electrical vehicles, why are you using discussing about, or all the scientists or all the professors are discussing and studying about the electrical vehicle? Electrical vehicles are our future. So we need to develop the electrical vehicles. As electrical engineers, we need to develop the electrical charges as possible as. So in our daily use for short distances or medium distance, we can use the electrical vehicle to decrease our pollution of the environment. So please use and aware the uses of electrical vehicles and keep the electrical charging stations also as possible as near. One of my stars said come with one plan. In every college having the electrical vehicle charging stations. Who that sir is my supervisor, Gurupur Nageswara sir, said about every college having electrical vehicle charging stations. It will help to increase the environmental effect and decrease the pollution. It will help to depletion of the ozone layers. All the effects of the fossil fuels, it will compact and compete with the electrical vehicles. So please use the electrical vehicle chargers, and thank you.
Thank you.
We the students of Lakreddy Valreddy and Chakula.
Our project is multi-level universal electrical vehicle chargers by controlling of voltage-oriented controllers and decrease the hormone distortion with using of artificial neural networks. I am the team leader of this project. My name is K. Nitin from Lakreddy Valreddy College of Engineering, EEE department.
I am the second person of this project, Kolsu Venkat Durga Bhavani. I am from the student of Lakreddy Balreddy College of Engineering.
I am the third person of this project. I am M. Kavya. I am the student of Lakreddy Balreddy College of Engineering.
Hi, this is Lasya. I am the fourth person of this project, and we are from the Lakreddy Balreddy College of Engineering, EEE department.
This project is under the guidance of Dr. Gurupur Nageswara sir, professor of LBRC.
And we are the students of Lakreddy Balreddy College of Engineering.